Problem 4 asks us to find the center 3, meaning C0, C1, C2, and C negative 1, C negative 2, those center 3 complex Fourier series decomposition components. We'll begin by defining the generator waveform of this. Let's use this little section right here between 0 and 1. So in that region, f of t is equal to t, since its slope is 1. And that's true for its time period, which is also 1. And that means its fundamental frequency is always 1 over its time period, which is 1 hertz. And that means its angular frequency is always 2 pi f, and so that is 2 pi. And the units of this are radians per second, and the units of this 1 is hertz. All right, given that, let's start finding our complex Fourier coefficients. Our C0 coefficient is this. But it's also a lot easier to notice that this is just the average value of the waveform. And half the time it's above 1/2, half the time it's below 1/2, so its average value is 1/2. Again, I think you can see that half the time we're above it, half the time we're below it. It's the average value. Okay, so let's find the first complex Fourier coefficient. It's equal to 1 over t. This is the general formula, times the integral over any time period of the function times e to the minus j omega naught n t dt. So let's fill in the values. Time period's 1, so 1 over 1 is just 1. We're going to integrate that between 0 and the time period, which is 1. The function is t. We'll integrate that times e raised to the minus j omega naught, we said, is equal to 2 pi. N is 1 for this example, times t dt. So this is a tough integral to do. It requires integration by parts. If I gave it to you on a test, I'd give you a table of integrals to help you solve it. If you saw it on the FE exam, they would give you a table of integrals. For now, I'll give you its solution. It's 1 over 4 pi squared times e to the minus j pi t plus j over 2 pi t e to the minus j 2 pi t with t evaluated between 0 and 1. And that collapses down to just j over 2 pi. And that's equal to, from your calculator, j times 0.159. Now, since you found out your C1, you instantly know your C sub negative 1 is just C sub 1 complex conjugate. So that's equal to minus j, 0.159. All right, that's half of the units. Let's find C sub 2. C sub 2, using the same formula, is 1 over t, which is 1 times the integral between 0 and 1 of f of t, which is t, e to the minus j omega naught, which is 2 pi, but now we're going to multiply that by our n of 2, t dt. So using the same integral lookup table we did, that gives us 1 over 16 pi squared e to the minus j 4 pi t plus j over 4 pi t e to the minus j 4 pi t. All that came out of a table lookup. We're evaluating it for t goes 0 to 1. And that whole thing collapses down to just j over 4 pi, which by our calculators is j times 0.07 0.96. So therefore our c to the negative 2, which is the complex conjugate of c to the positive 2, has to be minus j, 0.0796. And those are our answers.